Yo, what's up guys? Today we are going to be showcasing some of our personal all-time favorite Arduino Uno projects. It's going to be sick, mind-blowing, nerve-wracking and super amazing. Make sure to smash that subscribe button, click that notification bell and leave a comment down below on what you would like to see us do next.
In today's simple project, we will design a quick and easy laser beam security system. Let's go through the components needed for this project. An LDR is essential as it will sense the light from the laser beam. I will be using this Grove LDR module that looks a little bit different to the standard LDR. The buzzer is our alarm, which tells us when the beam is broken. Here is my Grove buzzer module. I'm using this green laser pointer. Of course, the Arduino Uno is the brain behind today's operation. This is a Grove shield that I'll be using in today's project, but just using the Arduino board will work perfectly too. Here's the code. As you can see, the LDR is searching for light values and does a certain condition when these values change. Connecting this circuit is quick and easy. All you need to do is connect the buzzer to digital pin 3 and ground, and the LDR goes to analog pin A0 and ground. And that's it, you're ready to go. It's quite important to do a test run before you do your actual final system. So as you can see, I got my serial monitor opened here, and my light in that room was about 100-200. As soon as I press the laser, it jumps to about 700. Now these values will change for you, and you'll just have to adjust them in the code. As I mentioned before, these are the values that you'll have to play around with to see which one works for you. Finally, all you need is to keep the laser on. I used insulation tape for this. Then, you need test subjects to break the beam. To make an effective security system, you are going to want the beams to be reflected multiple times. This will mean you will need a range of mirrors. Now I'm not going to go into high school physics, but take into consideration the law of reflection.
Hey guys, it's Dylan Young. Today we are going to be creating a temperature indicator. Over to you, Keenan.
Thanks, Dylan. Let us take a look at the components you will need to complete this project. You will need an Arduino Uno board, as this is the brain of the operation responsible for processing and running the code. The resistors in the circuit are connected to the LEDs, and this picture briefly explains why. The LEDs are essential components in this circuit as they indicate the different temperature levels, ranging from blue, which is cold, to red, which is hot. The LM35DZ is a transistor containing an IC sensor to measure temperature. This transistor is proved to be more accurate than a thermistor. The jumper wires are used to connect various components to various inputs and outputs, and this is all done on what we call a breadboard. This is the circuit layout. It is important to ensure that the flat side of the transistor is facing you when assembling the circuit, as this prevents you from reverse biasing the transistor, which in simple terms switches the transistor off. After this, you would be good to go. It is important to make reference to the circuit layout of the schematic diagram at least twice after assembling any circuit, as this eliminates any errors made in the circuit. We can finally run our code once that is done. Adjustments may be made with the temperature each LED represents. Temperatures may be lowered or raised. The blue LED is programmed to activate when a transistor senses a temperature less than 28 degrees Celsius. The yellow LED activates and the blue LED deactivates when a temperature equal to 28 degrees Celsius or greater is sensed. And finally, the red LED activates and the yellow LED deactivates when a temperature greater than 30 degrees Celsius is sensed.
Hey guys, it's Ian, and today I'll be showing you all how to make a bar graph. For this project, you will need an Arduino Uno with a USB cable, a minimum of 3 LEDs, colors of your choice, a breadboard, some wires, and a potentiometer. So now that we have all the components, let's get into designing this project. The first thing that I like to do is I start by placing the LEDs, which are one column away from each other. After that, I like to put the potentiometer a few columns away from the LEDs, as shown in the diagram. Next, I would take a wire and connect it to ground in the Arduino board and connect it to the negative rail on the breadboard. After that, I would connect all the negative legs of the LEDs to the negative rail on the breadboard. Then I'll take wires and connect the positive legs of the LEDs to the holes labeled 2, 3 and 4 on the Arduino board. After that, I would start connecting the potentiometer. The leg furthest on the right would go to ground, which is the negative rail on the breadboard. The middle leg of the potentiometer would be connected via wire to A0 on the Arduino board. And the last leg, which is the furthest left leg, would be connected to the 5 volts hole on the Arduino board. And now the circuit is completed and we can start writing the code. The coding for this project is quite simple, and all you need to know is that if you are adding LEDs, then you will need to change the number of pins to the amount of LEDs you are using, the LED pins to the values that you are using on your Arduino board, and you will have to change the amount of lows in your LED states to the amount of LEDs you are using. Once you have done uploading the code, your final product should look like this. Hey guys, I hope you enjoyed this video, and if you did, make sure you smash that like button, hit that subscribe button and turn on the notifications bell so that you keep updated with our new and latest videos. Thanks, bye.